Veterinary medicine operates under severe time constraints. Practitioners manage a constant triage of lab work, imaging, and incomplete histories, with only minutes to synthesize the data before making a critical decision. When new clinical AI tools enter this environment, they are almost universally judged by a single metric: their diagnostic accuracy compared to a board-certified specialist. Optimizing an algorithm solely to hit that high percentage creates what engineers call a black box. Clinical data feeds into an opaque engine, and a definitive answer emerges. But in clinical practice, an answer without a visible reasoning path has zero utility. If a veterinarian cannot see exactly how the algorithm weighed the liver enzymes against the radiographs, they cannot trust the output. A system built to simply guess the right answer hides its own mathematical logic. If the reasoning is invisible, errors cannot be intercepted before they reach the patient. Evaluating medical AI requires a shift in priorities. The critical question is not whether the system can guess correctly, but whether its underlying architecture is completely transparent. BELFI65 operates on a glass box model. It is a reasoning architecture engineered specifically so licensed veterinarians can audit its logic at every step of the process. This transparency is achieved through three specific architectural functions: high-dimensional data synthesis, active conflict detection, and strictly verifiable reasoning paths. These mechanisms are built to support the practitioner, not bypass them. The design guarantees that the human clinician remains the final, unquestioned authority in the diagnostic loop. Real utility in veterinary medicine requires a system that exposes its computational logic, rather than hiding its calculations behind a high-confidence score. A highly competent human clinician under pressure can actively hold and manipulate 5 to 7 distinct variables in their working memory at one time. This bottleneck is not a reflection of medical skill or experience. It is a strict biological limit. A typical internal medicine case routinely involves 50 or more clinical variables. A clinician must weigh species-specific breed predispositions, age-related risks, prior medical history, and dozens of individual values from a complete blood count and chemistry panel. Bridging the gap between a 50-variable case and a 7-variable human limit requires high-dimensional synthesis. This unique architecture analyzes dozens of distinct competing clinical data points simultaneously within a localized medical engine. Instead of reviewing a blood panel, and then looking at radiographs, and then reading the history, BELFI65 cross-references all these modalities together in one concurrent operation. Processing the data simultaneously allows the system to flag subtle correlations across different test results, correlations that are easily overlooked by a human doctor at hour 10 of a 12-hour shift. The value of the engine in this context is its capacity to act as a structural hedge against human cognitive overload. Biological data is rarely perfect. In many cases, the clinical findings will point in completely opposite directions. This chart shows two contradictory sets of data. On the left, radiographic signs strongly suggest heart failure. On the right, the patient's respiratory rate, heart rate, and blood work are completely normal. Confronted with this, a black box model will often smooth over the inconsistency. To maintain a high accuracy rating, the algorithm forces a single diagnostic guess, actively discarding the conflicting data. BELFI65 treats contradiction differently. When the internal consistency of a patient's data breaks down, the architecture refuses to pick a side. The system triggers a conflict detection protocol. It explicitly flags the contradictory findings for the veterinarian's immediate review. It then outputs a dynamic confidence score. This score does not reflect the algorithm's certainty. It measures exactly how well the multimodal data aligns. In medicine, ambiguity is not a flaw in the case. Uncertainty is a highly valuable piece of diagnostic information that guides the next step of testing. An algorithm that obscures data conflicts to produce a neat answer is actively creating the conditions for medical errors. The most frequent source of diagnostic error in human and veterinary medicine alike is a specific cognitive bias known as premature closure. Premature closure occurs when a clinician stops the diagnostic process the moment they find a likely, obvious cause for the patient's symptoms. BELFI65 systematically counters this bias. For every single case, it computes and generates a full, ranked list of differential diagnoses. This ranked list requires the practitioner to actively review look-alike conditions. Lookalike conditions are diseases with nearly identical clinical presentations to the primary suspect, which a rushed doctor might otherwise dismiss. If a computer suggests an unlikely lookalike condition, the clinician must be able to evaluate the exact medical literature supporting that leap. The architecture uses retrieval augmented generation, or RAG, to retrieve facts from an external knowledge base, grounding its responses in verifiable sources. Every recommendation the engine makes is hard-linked to peer-reviewed veterinary textbooks, ACVIM consensus statements, AAHA guidelines, and specialized staging protocols. By combining forced differential rankings with exact verifiable literature citations, the system ensures that when the veterinarian exercises their final override, that decision is informed by the data, not blind to it. In practice, this architectural transparency operates at speed. The workflow begins with the clinician narrating their physical exam findings hands-free into a live audio assistant. The system captures the dictation, translates it from any of over 100 languages into medical English, and merges that text with the uploaded lab results and digital imaging. The engine executes the high-dimensional synthesis, runs the conflict detection protocols, grounds findings through the RAG architecture, all of this simultaneously. Within 60 seconds, the system generates immediate, actionable outputs. This includes a fully formatted SOAP report ready for the clinic's management software, weight-based treatment protocols, and printed educational handouts for the client. Because this pipeline handles sensitive medical records, it employs a security standard called ephemeral processing. Ephemeral processing means that raw clinical data is scrubbed from the system's active memory immediately after the analysis is complete. Furthermore, BELFI65 operates under a strict zero training policy. Patient cases and clinical data are never used to train the weights of the foundation AI models. The result is a clinical pipeline that delivers deep diagnostic structuring and comprehensive case formatting, entirely without compromising patient privacy or slowing down the triage process. BELFI65 is not designed to act as an omniscient specialist. It does not exist to replace the diagnostic authority of the attending veterinarian. Its role is strictly that of a force multiplier. It handles the heavy computational lifting of multimodal data correlation and systematic bias reduction. By synthesizing the variables and exposing logic pathways, the system gives the doctor the verified information needed to communicate a clear plan to the owner. When the architectural management of complex data is delegated to a transparent glass box, the veterinarian is finally free to focus entirely on the practice of medicine.